Cambridge IGCSE, October-November 2021, Paper 41. Question 1. Some physical quantities are scalars and other physical quantities are vectors. State how a vector quantity differs from a scalar quantity. So this is 1 mark question. We just need to write one difference between scalars and vectors quantities. So the difference is vector quantities are the physical quantities. They have direction and magnitude. But scalar quantities only magnitude. So we can write down vector has a direction. Part B, circle the vector quantities in the list. So the physical quantities which has both magnitude and direction, we need to circle. So here we need to circle vector quantities. Acceleration is a vector quantity. Energy is not a vector quantity. Mass is not a vector quantity. Again, momentum is a vector quantity. Temperature is a scalar quantity. Time is also a scalar quantity. Speed is also scalar quantity. Then finally, velocity, again vector quantity. So we can circle acceleration, momentum and velocity. Part C. A microphone in a recording studio has a mass of 0.55 kg and a weight W. Calculate the weight. So we are provided with mass of an object and we need to calculate weight. So here we can use the equation weight is equal to mass times gravitational field strength. So mass is already provided times G value is 10, which is constant. So we will get 5.5 Newton. Since it is weight, it's a force, so the unit is Newton. So we will get 1 mark for writing this answer with the unit. Since it is 1 mark question, the working part is not necessary to score 1 mark. Part 2. The microphone is suspended from the ceiling by a cord attached to a small ring. So we can see the microphone which is suspended from the ceiling using a cord with a ring. And this microphone has pulled the other side using a horizontal thread as shown in the figure to keep the microphone stationary. So this point is very important, that the microphone is stationary now. From this we can understand it is in equilibrium. The tension T in the horizontal thread is 8.1 Newton. So the tension in the horizontal thread is given. So the tension is 8.1 Newton, which is given. Let's continue reading the question. Determine graphically the magnitude and the direction relative to vertical of the resultant of weight and tension. Use a scale of 1 centimeter to 1 Newton or greater. So in this question we have to determine the resultant vector of weight and tension by vector diagram, where we have to take a scale. As mentioned, we can draw 1 centimeter line to represent 1 Newton force. So we have to draw the lines accordingly or using this scale. So let's look at the diagram, and here we can see the tension which is acting horizontally towards right and which is 8.1 Newton, and weight will definitely act downwards towards ground. So these are the two forces acting, and weight we have already calculated in the previous session, that is 5.5 Newton. So we have weight 5.5, that is vertically downwards, and tension which is 8.1 Newton, that is horizontally towards right. So in order to draw a vector diagram, first we can draw the tension which is 8.1 Newton towards right, horizontally right. So you should take a ruler and draw with a pencil that 8.1 centimeter line. It should be straight line. You should draw using ruler. That is very important. And the length should be 8.1 centimeter. So that represents 8.1 Newton, and which is nothing but tension, because our scale is 1 centimeter representing 1 Newton. So in order to represent 8.1 Newton, we should draw 8.1 centimeter. Next, we can draw the other force, that is weight. And as we can see, it is vertically downward. So we should draw vertically downward. But when we drawing, we cannot draw this side like this, because if you are drawing in this way, you can see the tail of one vector is touching the tail of the other vector. That is not possible. When we are drawing, the head of one vector should connect with the tail of the other adding vector. So here we have to connect the weight only at this side, and this should be 5.5 centimeter. You should take a ruler and make sure the length is 5.5 centimeter, and that we can write down nothing but it represents 5.5 Newton, and that is weight. Now we need to connect the third side of the triangle, and that will be the resultant. So this is the third side, and this side represents the resultant. Now the direction of resultant vector is very important. We can see the tension and weight both are in same direction or in clockwise direction. Third side should be in opposite direction or in anti-clockwise direction. That means the resultant vector must be connecting the head of one vector to the head of the other, or the tail of the other vector should connect with the tail of the resultant vector. In such a way, you should draw or decide the direction. So this third side is the resultant vector, and in order to know how much Newton it is, you have to take a ruler and measure this length. So you will get it is 9.6 centimeter. So 9.6 centimeter is nothing but 9.6 Newton. You can get an answer in the range 9.6 to 10 Newton. If your answer is in between this range, you will get full mark. So we got the magnitude, but not only the magnitude, we need to know the direction also in terms of angle, because it's mentioned relative to vertical, we have to specify. So we need to measure the angle with respect to vertical. So this is the angle we need to measure. You can use a protractor, and the answer is 54 degree. Again, for the angle also, you can get an answer in the range 54 degree to 57.5 degree. So if your answer is this range, in between this value also, you will get full mark. So please make sure you have to measure both the resultant magnitude, that is the length, and angle in order to score full mark. So in magnitude we can write 9.6 Newton, and direction relative to vertical, if we have measured, that is 54 degree. Part 3. State and explain how the magnitude and direction of the resultant in C2 compares with the force on the ring due to the tension in the cord. So here we are asked to write down in terms of force in the cord. We have to relate that with the answer which we have got. So here we have already find out what is the resultant force of these two forces, and we already got that is something in this direction, and its value is 9.6 Newton. So in order to make this microphone to be stationary or not to go with the direction of this resultant force of the tension and weight, we have to apply a equal force in this cord. then only we can keep it constant. So we should apply a 9.6 Newton equal force but in opposite direction of the resultant force in order to make the microphone stationary or at that point again without moving in the direction of the resultant force of the tension and weight. So we can write down, as the ring is in equilibrium, the force on the ring will be equal in magnitude. That means there must be an upward 9.6 Newton force, but the direction should be opposite. So that also we should mention, but opposite in direction. So here this is very important, must be equal in magnitude but opposite in direction. You will get 2 marks. Part 2, a student carries out an experiment using a plastic beaker that contains 0.24 kilogram of water at 17 degrees Celsius. The thermal capacity of the beaker is negligible. Define thermal capacity. So in this question we have a plastic beaker which consists of 0.24 kilogram of water at temperature 17 degrees Celsius. So this definition you need to memorize. Thermal energy required to increase the temperature of an object for 1 degree Celsius. That means here in this particular example we have a beaker where the temperature of the water is 17 degrees Celsius. In order to increase its temperature 1 degree Celsius to 18 degrees Celsius, how much energy we have to supply? How much thermal energy we have to supply? That is known as thermal capacity or heat capacity. Question B. Several ice cubes are at a temperature of 0 degrees Celsius. The ice cubes are dropped into the water and the internal energy of the water decreases. Give a simple molecular account of this decrease in internal energy. So we just need to know when the temperature decreases, what will happen to internal energy. So here we need to know that when temperature decreases, as the ice cubes are dropped into this water, the temperature of the water will definitely decrease. So whenever the temperature decreases, the internal energy of the molecules of water will also decrease, and this internal energy is depending upon the kinetic energy of the water molecules. So when the temperature decreases, as the energy decreases, the molecule will start to move with less speed. Because of that, the kinetic energy will be less. And because of the less vibration between the particles or molecules, because of less kinetic energy, the spacing between the molecule will also be less. Because of that, we can say even the potential energy of these molecules will be also less. So these are the points we can include. So first point we can write, internal energy depends on the kinetic energy of the molecule. This is very important. For any object, if we have its internal energy means sum of its kinetic and potential energy. And when temperature drops, the kinetic energy and potential energy also will reduce. And second point we can write, when temperature decreases, what will happen to this kinetic energy? So we can write kinetic and potential energy decreases when temperature decreases. This is a very important point, that kinetic and potential energy decreases when temperature decreases. It is applicable for all the system. Part 2. The specific heat capacity of water is 4200 joule per kilogram degree Celsius. Calculate the decrease in internal energy of the water as the temperature decreases from 17 degrees Celsius to 0 degrees Celsius. So here temperature drop is given. We can find out delta T, the difference in the temperature. Specific heat capacity C is given. Mass of this water is already given in the first part, that is 0.24 kilogram. So we have the mass also. So mass is 0.24 kilogram, and we need to calculate decrease in internal energy. That means the change in internal energy delta E, which we need to calculate. So we can use the equation which relates energy and specific heat capacity, so that the equation here we can use it. Change in energy or change in internal energy is M, that is mass, times the specific heat capacity times the change in temperature. So here we have all the values, that the mass is 0.24, which is given in first part, times specific heat capacity is 4200, times change in temperature is 17 degrees Celsius minus 0 degrees Celsius. So that our answer is 1.7 times 10 to the power 4. So we can write 1.7 times 10 to the power 4, and since it is energy, the unit is joule. Part C. As the temperature of the water decreases, some of the ice melts. Explain why this ice melts. So here we need to explain, when the ice cubes dropped in water, some of the ice melts. The reason behind it. So the first point we can write down, ice cubes absorb thermal energy from the water, or heat will transfer from water to ice cube. Then we can write ice cube molecule use this thermal energy to break the bond between the molecules, or to break the intermolecular bonds. So this is a 2-mark question. So the important keywords are absorb thermal energy from water to ice cubes. And the second point, for using this thermal energy, the ice cubes break the intermolecular bonds. These are the keywords. It must be there in your answer sheet in order to score 2 marks. Part 2. Describe how to determine the specific latent heat of fusion of ice using this experiment. State any other measurements that the student needs to make. So we have to explain an experiment to calculate the specific latent heat of fusion of ice. So in this question, we have to explain an experiment to describe how to determine the specific latent heat of fusion of ice. So initially we have a container which consists of water at 17 degrees Celsius, 17 degrees Celsius, which is already given in the question at the initial part. Then few ice cubes which are at 0 degrees Celsius dropped in this water. Now we need to measure experimentally that how much energy these ice cubes required to convert from ice to water at 0 degrees Celsius. That is nothing but latent heat of fusion. So we have to measure the latent heat of fusion experimentally here. So initially we can check which equation relates to the latent heat. So we can understand the energy is equal to mass times latent heat of fusion. So in order to calculate latent heat of fusion, we can rearrange. So we can understand the energy supplied to the ice to convert from ice to water at 0 degrees Celsius over the mass of the ice cubes which have melted into water. So here we just need to know or measure the mass of melted ice. Then we need to know the value of E. E value we already have in the previous section. So first we have to measure the mass. In order to measure the mass of the ice which has melted, we can initially measure the mass of the water. Then after some time again we can measure the mass of the water. In the second mass there will be additional mass of the ice melted also will be there. So by just subtracting we will get the mass of the ice melted. So So initially we can write use the equation that is latent heat of fusion is the energy over mass. Then we can write to measure m or mass of ice melted. Determine the increase in mass of water. How much water mass has increased. That increased amount must be from ice. But when we are doing the experiment, we have to make sure that we should use an insulate beaker because the energy should not lose to the surrounding. So we can write another additional point. Use insulated beaker. Question 3. Figure 3.1 shows a balloon inflated with air. The pressure of the air at the inner surface of the balloon keeps the rubber stretched. Explain in terms of momentum of the molecules why there is a pressure at the inner surface of the balloon. So this is a frequently asked question in many past papers and very important question that we need to explain in terms of momentum how the pressure at the inner surface of a container experienced due to the gas inside it. This is a 3-mark question, so we have to include some important keywords. The first we can write the molecules inside the balloon or the molecules of air inside the balloon. They collide with the inner walls or the inner surface of the balloon and they bounce back. So this will cause them to change the momentum as the direction changes. So the first point we should write the molecules collides with the inner surface, and the second point we can write because of this collision of molecules on the wall they bounces back. So this will cause a change in momentum. So the momentum of these molecules changes. That means there is a change in delta P. And next point we can write when these molecules collides at the walls, they exert a force on the walls. Therefore we can write these molecules when they collide with the walls exert a force on the walls of the balloon. And this force is actually spreading all over the surface of the balloon. So that is the fourth point we should mention. The force is actually spreading on a surface. So we know that if there is a force over area which will cause a pressure. So these are the important points we must include and which is a frequently asked question. So we can write all these points. So second point we can write molecules exert a force and this force spreads over the area. You can write one additional point about the momentum. As the molecules collide with the walls, their direction changes, so the momentum of the molecules will also change. So we can write momentum of the molecules change and this causes a pressure. As pressure is nothing but force over area and we have seen there is a force exerting and over an area, so definitely this molecule will exert a pressure on the wall of the balloon or any container. Part B, the volume of the balloon in the Part B, the volume of the air in the balloon is 630 centimeter cube and the pressure of the air in the balloon is 1 into 10 to the power 5 Pascal. So the volume of the air in the balloon is given, let it be V1, that is 630 centimeter cube, and the corresponding pressure is also given, that is 1 into 10 to the power 5 Pascal. The balloon is tied to a heavy stone and dropped into a lake. The balloon is pulled down quickly and the temperature of the air remains inside, does not change. So the balloon is pulled down in the lake and which tied with a heavy stone. Part 1. Calculate the volume of the air when the pressure of the air is 1.4 into 10 to the power 5 Pascal. So now new pressure that we can represent it with P2 is given, that is 1.4 into 10 to the power 5 Pascal. As the balloon is inside the lake water, definitely the pressure will increase. So we need to find out what is the corresponding volume. So here we can use Boyle's law equation, that is P1 V1 is equal to P2 V2, and we need to calculate V2, so we can make V2 as the subject. So we will get P1 V1 over P2, where initial pressure is 1 into 10 to the power 5 times initial volume is 630 over P2, that is the pressure of balloon in water, that is 1.4 into 10 to the power 5, and we will get 450. So the answer is 450, and the unit here it is centimeter cube. Part 2. The balloon and stone stop moving when the stone hits the bottom of the lake. The temperature of the air now begins to decrease. Explain why the volume of the air in the balloon decreases as the temperature decreases. So in this question we need to explain when temperature decreases, how the volume of the balloon will also decrease. What is the relation between temperature and volume? So first point we can write, the temperature is directly proportional to kinetic energy. So as the temperature is directly proportional to kinetic energy, when temperature decreases, kinetic energy decreases. Because of that, the molecules collide less frequency, so automatically the volume of the balloon will reduce. Since it is 2-mark question, these 2 points are enough. Question 4. A train of mass 1.8 into 10 to the power 5 kilogram is at rest in a station at time t is equal to 0. The train begins to accelerate along a straight horizontal track and reaches a speed of 20 meters per second at time t is equal to 15 seconds. The train continues at a speed of 20 meters per second for 10 seconds. At time 25 seconds, the driver applies the brakes and the resistive force on the train causes it to decelerate uniformly to rest in a further 24 seconds. Figure 4.1 is an incomplete distance time graph for this journey. So we are provided with the information about the journey of a train. So let's study the time interval and the motion of the train in between different time interval. So at time t is equal to 0, the train is at rest. That means initially the train is at rest. So we can write, when the time is 0, the train is at rest, or its speed is 0 meter per second. Then the train begins to accelerate to a straight horizontal track and reaches a speed of 20 meter per second in 15 seconds. That means from 0 to the 15th second, the train accelerates. And finally, it reaches a speed from 0 meter per second to 20 meter per second. So at the end of the 15th second, the speed of the train is 20 meter per second. Then after 15th second, the train continues at a speed of 20 meter per second for 10 seconds. That means then for next 10 seconds, the car is moving with a uniform speed, and that uniform speed is 20 meter per second, and the time is the next 10 seconds from 15 seconds. That means from 15 seconds to the 25 seconds. Then at the end, at 25th second, the driver applies brake, it's mentioned here, and the train decelerates uniformly to rest for further 24 seconds. So after 25th second, it took 24 more seconds. That means 25 seconds to 49 seconds. The car decelerates and it stops. So at 25th second the speed was 20 meter per second, then it stops to 0 meter per second. So during the last 24 seconds the train is decelerating. So basically 4 different types of motions are happening for the train. Now let's look at the first part. We need to complete figure 4.1. We need to complete the graph where first part, a line to represent the motion of the train between 15 seconds to 25 seconds. In order to complete the graph between the time interval 15 seconds to 25 seconds, we can look at the motion of the graph between the time from 15 seconds to 25 seconds. So the time interval in between 15 seconds to 25 seconds, the train is moving with a uniform speed, and that is 20 meter per second. So during this time interval, the speed is 20 meter per second, and the time taken from 15 seconds to 25 seconds is 10 seconds. So we can even calculate the distance covered using the equation. Speed is equal to distance over time, where we have the distance we don't have, so we can calculate what will be the distance covered by the distance covered by the train during this time interval by rearranging the same equation and make distance as the subject. So we will get speed times time. So the speed is 20 meter per second times time is 10, so we will get 200 meter. So 200 meter is the distance traveled by the train during this time interval. Why we have to calculate the distance? Because look at the graph in figure 4.1 on y-axis. It's given the values of distance. So in order to plot this graph, we should know the distance traveled by the train. So now we can understand that during 15 to 25 seconds, the train has traveled a distance of 200 meter. This is very important. Now we can look at the graph on x-axis. Which points represent the time interval 15 and 25? So we can see this point represents the time 15 seconds, exactly in between 10 and 20, and this point exactly in between 20 and 35 is representing 25 seconds. So during this time interval, the train is moving with a uniform speed. Uniform speed means the distance time graph will be straight line because the train is covering equal distance as its speed is constant. So it must be a straight line. So we have to plot a straight line, and the end point is 25 where we have the graph. So you need to plot till this point. But what is the initial point at 15th second? This one we need to know. For that we can use this information, that is the distance covered by the train during this 10 seconds is 200 meter, and at the end of 25th seconds the distance covered is 320. We can understand by extending this 320 meter. So 10 minutes before or the starting of 15th second, the train must be 200 meter behind, because we know that it has traveled 200 meter in this 10 seconds. So the initial position must be 200 meter behind. That means 320 minus 200. So we will get 120 meter. So the train was at 120 meter at 15 second. So on y-axis again we can find where is 120 meters. So we will get this is the point where the distance represents 120. So this must be the point where you can see the distance of the train is 120 meter where the time is 15 seconds. So this is the initial point. And now the train is traveling during this section with a uniform speed, so we know that it must be a straight line. So this must be the shape of the graph during this session. Next, part 2, we have to plot a curve to represent the motion of the train between 0 to 15 seconds. So let's look at the motion of the motion of the train between the time interval 0 to 15 seconds. We can understand it accelerates. So accelerated motion, the distance time graph will be always a curve. Since it is accelerating, the curve should be upwards. So you can plot curve like this. Then it should continue to be straight line. So this is the graph of the motion of the train. Part B. Calculate the kinetic energy of the train between 15 seconds to 25 seconds. So kinetic energy equation, we need to write that is half mass times velocity square, where mass is given, that is in the starting itself the mass is given, which is 1.8 into 10 to the power 5. So we can substitute mass 1.8 into 10 to the power 5 times what is the velocity. Velocity of the train during this time interval 15 to 25 seconds, we already know that is mentioned, which is 20 meter per second. So we have the velocity which is 20 meter per second, and we have to square it because it's v square. So we have to square, and the answer is 3.6 times 10 to the power 7 joule. So the kinetic energy of the train is 3.6 times 10 to the power 7. We should write the unit, since it is energy, unit is joule. Part C. While the train decelerates to rest, it does work against the resistive force and its kinetic energy decreases. Define work done. So define means we can write the word equation of work done. So work done is equal to force times distance. But which distance? That is very important. Distance moved in the direction of motion. This you should specify in order to score full mark. Since it is 2-mark question, you will get 1 mark for writing work is done is force into distance. And the second mark is for specifying moved in the direction of the motion. Part 2, using figure 4.1, determine the distance moved by the train while decelerates. So let's look at the graph again. And by looking at the graph, we can understand the deceleration is from 25 seconds. Even it is mentioned, the train decelerates from 25 seconds to 49 seconds. So we need to find out the total distance traveled by the train during this time interval. So the distance is already given on y-axis. So just look at the y-axis value during this section. To know that, we can extend the values starting point and ending point to the y-axis, and we can just subtract. So we can see here it is 320 initial position, and at the end of the deceleration the train is at a position 560. So the total distance covered by the train must be 560 minus 320. So the answer is 240 meters. So we can write down 240 meters. Since it is 1-mark question, we don't have to show any working. Part 3, calculate the resultant force acting on the train while it decelerates. In order to calculate resultant force, we can use the equation force is equal to mass of the train times acceleration of the train during this section. We have mass, but we don't have acceleration or deceleration during this section. So we need to calculate acceleration. So the acceleration is change in velocity over time, where the final velocity of the train is 0. Initial velocity of the train during this time interval at 25th second is 20 meter per second, over the time taken is 24 seconds. It's already mentioned in the question. During the deceleration section, only we have to check. Here it takes only 24 seconds and the initial velocity was 20 meter per second. We know that initial velocity is 20, final velocity is 0, and the time taken is 24 seconds. So we have time, we have initial velocity and final velocity. We can substitute and we can get the acceleration during this section. So we will get minus 0.833, and since it is deceleration, we don't have to put negative sign, because negative sign simply indicates its speed is reducing. Now we can substitute this value. So force is mass times, where mass is given in the starting point, that is 1.8 into 10 to the power 5. So we can substitute mass is 1.8 into 10 to the power 5 times acceleration is 0.833, and that answer is 1.5 times 10 to the power 5. Since it is force, the unit is Newton. So 1.5 times 10 to the power 5 Newton is the answer. Question 5, Part A. Explain in terms of the behavior of light rays what is meant by principal focus for a thin converging lens. So if we have a thin converging lens and a principal axis passing through the center of the lens, principal focus is a point where parallel rays, all the parallel rays will meet after passing through the lens. So the point where all the parallel rays meet, so this point is known as principal focus. So as a definition we can write, it is a point on a principal axis where parallel rays meet after passing through the lens. Part B. State what is meant by principal focus. Focal length. Part B. State what is meant by focal length. So we have already seen what is principal focus in the previous part. So focal length is the distance between the principal focus and the center of the lens. So this length is called focal length. Therefore we can write it is the distance between the principal focus and optical center. Optical center is the center of the lens. Part C. A lens is used to produce a focused image of an object on a translucent screen. Figure 5.1 shows the object O and its image I. So here we can see the object and the image. Image is inverted and magnified comparing to the size of the object. It's clear from the graph. Part 1. Consider the straight ray that passes from the tip of O to the tip of I and find the position of the lens. Mark the position of the lens by drawing a vertical line labeled L from the top of the grid to the bottom. So first we can draw a straight ray or line that passes from the tip of the object O to the tip of the image I. After drawing this straight line, we can find the position of the lens. So let's initially draw a line which is starting from the tip of the object to the tip of the image I. So you need to take a ruler and a pencil in order to do this. And this is the tip of object O and this is the tip of image I. So let's connect a straight line between these 2 points. So you should take a ruler and draw. It must be straight line between these 2 points. So the first part we already done, that we have drawn a straight ray that passes from the tip of object O to the tip of I. Next we need to find the position of the lens, and after finding the position of the lens we need to mark the position of the lens by drawing a vertical line labeled L. So we have to first identify where is the position of the lens. So position of the lens will be at the point where this particular line meets the principal axis. So this is the point where the lens should be placed in order to get an image in this way. So we can draw a vertical line in order to represent this particular position of the lens. And we have to label it as L as mentioned in the question. So this is a vertical line where we must kept a lens in order to get an image as shown in the figure. Let's go to next part. On figure 5.1, draw a ray that passes through one of the principal focuses and determine the focal length of the lens. So next we have to find out principal focus. So principal focus is the point as we already mentioned. First we need to draw a parallel line emerging from the object. When it meets the or enter the lens, it will pass through the lens and meet at the tip of the image. So in order to find out the principal focus, we should draw a parallel ray emerging from the object, and when it reaches at the lens, it will be diffracting and passing to the image tip again. Now we can check this particular line where it meets at the principal axis. So we can find this is the point where this particular line meeting at the principal axis. So this must be the principal focus, and we need to find the length or the length of the principal focus. So we have already mentioned length of the principal focus is nothing but the length between this principal focus and the center of the line. This is focal length. And in this graph it's already mentioned 1, 2, 3, 4, 5 boxes. 5 small boxes represent 1 centimeter. So here we have such 15 boxes. That means 5 small boxes equal to 1 centimeter, which is given here. So when we measure the length of principal focus, we can understand there are 15 such small boxes. So it must be 15 times 5, so we will get 3. So 3 centimeter is the focal length, or the length between these 2 points must be 3 centimeter. So we can write the focal length is 3 centimeter. You can get an answer in the range between any value between 2.8 centimeter to 3.2 centimeter. Any measurement in between this range, you will get full mark. And please make sure to draw the principal axis on the graph in order to score 2 marks. Part 3. Object O is a printed document that includes a large letter R on the side facing the lens. The top edge of the document corresponds to the tip of O. Figure 5.2 shows the printed document. On figure 5.3, mark a tick on one of the boxes to indicate how the image on the translucent screen appears to someone who is looking at the screen from the point P. Explain why the image has this appearance. So we have to see that when someone is looking from position P, when a letter R has kept where the object O placed, how he can see. So we can understand from this given figure that the image must be inverted. So we can see the letter R as an inverted one if we are looking from the position P as mentioned. So therefore the correct answer is R. We will be able to see the inverted letter of R. And we need to write the reason. We can simply write the reason is it is inverted, which is clearly seen in the figure. So here 1 mark we will get for identify which of this box is correct, and the second mark is for writing the reason. So the inverted is enough to score the second mark. Question 6. X-rays are electromagnetic waves. Figure 6.1 shows the position of X-rays in the electromagnetic spectrum arranged according to increasing wavelength. Part A. 3 components of the spectrum are unnamed but labeled J, K, L. State the name of these 3 components. So, we are provided with the electromagnetic spectrum in increasing wavelength order. So, we need to identify which EM waves represents J, K and L. In order to answer this question, you need to memorize the electromagnetic waves orders according to their wavelength. So after X-rays, it's ultraviolet rays, and after visible light, it's infrared radiation, and after microwave, the electromagnetic radiation which is having the highest wavelength, which is radio waves. So we can fill these JKL as ultraviolet, infrared and radio. Part 2. State which of these 3 components has the lowest frequency. So again we can see the figure 6.1 and we can identify that the radio wave has the highest wavelength because it's given the increasing wavelength order. So the last one is radio wave. So the wavelength will be maximum for radio waves. Therefore, the frequency which is in opposite way or inversely proportional. So the frequency will be minimum for radio waves. Therefore, we can write the components which has the lowest frequency must be radio wave. Part B. Calculate the frequency of X-rays that have the wavelength 1.2 times 10 to the power minus 9 meter. So we are provided with the wavelength that is 1.2 times 10 to the power minus 9, and it is a X-ray which is an electromagnetic wave. So the speed is always constant, that is 3 into 10 to the power 8 meter per second. So we have speed and wavelength. We need to calculate frequency. Therefore, we can use the equation, wave equation, that is speed is frequency times wavelength. In order to calculate frequency, we can make frequency as the subject. So you will get frequency is equal to speed over wavelength, where speed is 3 times 10 to the power 8. Over wavelength is also given 1.2 times 10 to the power minus 9. And the answer is 2.5 times 10 to the power 17 Hertz. So that is the frequency, 2.5 times 10 to the power 17 Hertz. We should write the unit of frequency in order to score full mark. This is a 3-mark question. So in order to score 3 marks, you should write the equation and you should be able to identify the speed is 3 into 10 to the power 8 and final answer with the unit. All these steps are important in order to score 3 marks. Part C. Describe one of the medical use of X-rays. It is 3-mark question. So we need to include 3 points minimum. So first we can write X-rays used to treat cancer and we need to explain how. The first point we can write X-rays will be absorbed by the tumor cells in the organ. High energy X-rays can kill these cancer cells or tumor cells. Part 2. State one reason why it is necessary to take safety precautions when X-rays are used. So we have already seen these X-rays are very high energy electromagnetic rays, so they can cause burns or cell damage. Since it is 1-mark question, this much is enough. Question 7 is from static electricity. A plastic rod becomes negatively charged when it is rubbed with a woolen cloth. Part A, describe in terms of particles how the rod becomes negatively charged when rubbed with the cloth. So here we have a plastic rod and a cloth. And it's mentioned that when the plastic rod is rubbed with the woolen cloth, the plastic rod becomes negatively charged. That means the electrons from the cloth is transferring to the rod, so that the rod will gain more number of electrons and the cloth will lose electrons. So the plastic rod will become negative charge and cloth will become positive charge because of the absence of. So we can write negatively charged electrons will transfer from cloth to plastic rod. Part B, a light conducting ball is at rest on a metal table. When the rod is brought close to the ball, as shown in figure 7.1, the ball jumps up towards the rod. Explain why the ball jumps up. So here we already know that the rod is negatively charged as it rubbed with the cloth. So the rod is now full of negative charges, and when we bring this ball close to the rod, all the electrons in this ball must be repelled by this negatively charged rod, and all these electrons will move to the earth through this metal rod. All the electrons in the ball will be transferred from ball to the metal rod. The reason is this negatively charged plastic rod will repel all negative charges from the balloon, so that in the ball there won't be no negative charge, or the number of charges of positive charges will be more. Now the ball is positively charged, rod is negatively charged, so the opposite charges will attract, so that the ball will get attracted to the rod, as the rod is negative charge and the ball is positive charge. So first point we can write down all the electrons from the ball will be repelled to the earth. So the electrons repel to the earth and ball become positive charge. Then we can write, so ball will get attracted to the plastic rod as opposite charges attract. Part 2, the ball touches the rod and falls back down to the table. Explain why this happens. So here, once this ball gets attracted to the rod, the ball will absorb these negative charges from the rod to the ball. Now both are in the same charge, negative charge, so no more attraction, so that the ball will fall down. So we can write down, the ball discharges by the plastic rod by absorbing electrons from the rod. Therefore both ball and the rod is also negatively charged, so they will be repelled. Hence we can write ball will be repelled by the rod. Question 8 is from electricity. A circuit contains two fixed resistors and a light dependent resistor. Figure 8.1 shows that the power supply is 9-volt battery. The current in the 450 ohm resistor is 0.012 ampere. State what is meant by electric current. So in order to define what is electric current, we can use the equation of electric current, that is nothing but rate of flow of electric charge. So we can write down I equal to Q over T, or in words you can write rate of flow of electric charge. Since it is 1 mark, 1 point is enough. Part B, the current in the LDR is I1 and the current in the 800 ohm resistor is I2. Complete the equation that relates the current in the 450 ohm resistor to I1 and I2. So let's look at this circuit again, and we have to label the current in the LDR as I1 and the current in the 800 ohm resistor as I2. So the current in the LDR which we should represent as I1, and we know that the current will be always flowing from the positive side of the cell to the negative side of the cell. So this is the direction of the current. That means current direction is in this way, and when the current reaches at the junction, it splits into two, and the current flowing through the LDR we should represent as I1, and the current flowing through 450 ohm we should represent as I2. The current flowing through 800 ohm resistor we should represent as I2, and there is another current is flowing, must be flowing through the resistor 450, let it be I3. So we can identify here that I2 must be the sum of I1 and I3, because the current reaching through the I2, when it reaches at this junction, it splits into I1 and I3. So we can write down I2, the current passing through 800 ohm must be splitting and passing through I1 and I3. So I1 plus I3 must be I2. Now we need to write an equation for I3, the current passing through 450 ohm, that must be equal to I2 minus I1. So here we can write down the current passing through 450 ohm must be I2, the total current passing through 800 ohm, minus the current passing through the 8 LDR. Part C, calculate the power dissipated in the 800 ohm resistor. So we have to calculate the power dissipated at 800 ohm resistor. Part C, calculate the power dissipated in 800 ohm resistor. So we have to calculate how much power dissipated in 800 ohm resistor. So here we know the resistor value is 800 ohm, but we don't know what is the voltage across this 800 ohm or even the current passing through the 800 ohm. So we need to find out either V or I, then we can calculate power. So we can use this equation, power is equal to V square over R, and we have R value already. So if we can calculate the potential difference across 800 ohm, we can substitute the values and hence we can calculate power. So first we can find out what is the voltage across 800 ohm. We know that the total voltage or potential difference is 9 volt. Now we can find what is the potential difference or potential voltage drop across this parallel combination. By knowing that, we can simply subtract the total potential difference and the potential difference across this parallel combination. So we will get the potential difference across 800 ohm. So first we can calculate what is the voltage across this parallel combination, or what is the voltage across 450 ohm. In order to calculate this, we can use this given information, that is the current passing through 450 ohm resistor is given. So we have the I value and we have the R. So we can calculate what will be the voltage drop, that is voltage drop across 450 ohm resistor must be equal to V equal to IR. We can use this equation where I is given, the I passing through 450 ohm resistor is 0.012 times resistor is 450. So we will get 5.4 volt. That means there is a voltage drop across this parallel combination, and that voltage drop is 5.4 volt. So out of 9 volt, 5.4 volt has dropped across this parallel combination. So that remaining voltage will be across 800. So that voltage must be 9 volt minus the voltage drop across the other components in the circuit. So we will get 3.6 volt. So we have voltage that is 3.6 volt here, and we have resistor 800. So we can use this equation in order to calculate power. So we can write power is V square over R, where the voltage is 3.6 square over resistance is 800, and the answer is 1.6 times 10 to the power minus 2 watt. Since it is 4 marks question, we need to show all the working which we have done here. All these working should be shown in this given space in order to score mark. So all the working should be shown in the given space to score 4 marks. D. The brightness of the light that is incident on the LDR increases. Explain what happens to the potential difference across 450 ohm resistor. So let's look at the circuit diagram again. So here, when the light intensity falling on the LDR increases, the resistance across the LDR will reduce. When the resistance of the LDR reduces, we need to understand the resistance of this parallel combination will also reduce. So because of the resistance of LDR reduces, resistance of the parallel combination will also reduce. When the resistance of this parallel combination reduced, we can understand that the voltage drop across this parallel combination will also reduce. So the voltage drop across 800 ohm will increase, as the total voltage of the whole circuit is 9 volt. When voltage across parallel resistor combination reduces, voltage across 800 ohm will increase. So these are the points we can include in order to score 3 marks. When brightness increases, resistance of the LDR decreases. This is the property of LDR. Next point we can write, as the resistance of the LDR decreases, the resistance of the parallel combination will reduce. So that is the next point, resistance of the parallel pair decreases. When the resistance of the parallel pair decreases, the voltage drop across the parallel pair or 450 ohm resistor will reduce, and the voltage across 800 ohm will increase. So we can write that point next. So the potential difference across 800 ohm increases and potential difference across 450 ohm resistor decreases. 450 ohm resistor is nothing but the PD across the parallel combination decreases. Question 9. Uranium-335 is a radioactive isotope of uranium that occurs naturally on Earth. Describe the composition and structure of a neutral atom of uranium-235. This is a 4-mark question, so we need to explain the composition and structure with minimum 4 points. First, we can describe basic structure of a atom. Therefore, we can write uranium-335 has a very small nucleus and surrounded by electrons. This point we can write for any atoms. Next, we can write about the number of protons and neutrons. As it is a neutral atom, the number of electrons and protons will be same. Let's look at the number of protons in this atom. So we are provided uranium-92 and 235. So by looking at the atomic number, we can identify what is the number of or how many protons are there, because atomic number always represents number of protons, and it is nothing but 92. So it has 92 protons, and since it is a neutral atom, number of protons must be equal to number of electrons also. And you have to be very careful. It is only because this atom is neutral. So we can write down number of protons and electrons are 92. Next, we can find out number of neutrons. Number of neutrons by looking at the mass number. the number of neutrons will be the mass number minus number of protons, which we have 92. So we will get 143. So 143 neutrons also there in this particular atom. So we can write 143 neutrons present. And last point we can write down, protons and neutrons reside inside the nucleus. So these points are enough to score 4 marks. Part B. Another isotope of uranium is uranium 338. Describe how an atom of uranium 238 differs from an atom of uranium 335. So here we have two atoms. One is uranium 335 and another one is uranium 338. Uranium will always have the same atomic number, that is 92. So these are two isotopes of uranium. Now we have to describe what are the difference between uranium 235 and uranium 238. So we can identify that there is 3 more neutrons in the nucleus of uranium 238. Uranium 238 has 3 more neutrons in nucleus. Since it is 1 mark question, 1 point is enough. Part C. In a reactor in a nuclear power station, a nucleus of uranium 235 absorbs a slow moving neutron and then undergoes nuclear fission. 2 neutrons, a nucleus of xenon 140 and a nucleus of an element represented by E are produced. Complete the equation for this fission reaction. So this is the equation for this fission reaction, where we can see 1 neutron. So the neutrons always represent 0, 1, 1 for the mass number. And at the RHS of the equation we have 2 neutrons. So 2 neutrons means it represents 2 at the mass number and 0 at the bottom. So this is the available information we have, and we have a new element E at the right hand side. We need to find out what is the atomic and mass number. So we can look at the mass number, and mass number is conserved. That means the total number of mass at the LHS must be equal to the total mass number at the RHS. That means at the LHS we have 1 for the neutron plus 235 for the uranium atom. So the total mass number at the LHS is 236. Therefore, the mass number at the RHS also should be 236. That means for xenon it is 140 plus for unknown element E we don't know, so let it be E itself, plus for 2 neutrons it is 2, that is 236. So in order to find out what is the value of E, we can take 140 and 2 to the other side. So we will get 94. So at the mass number it must be 194 for this new element. And now we can look at the atomic number. So at the LHS of the equation it is 0 plus 92. So the total is 92. Therefore at RHS also it must be 92. So 54 plus the unknown value must be equal to total 92. So in order to find out this unknown value, we need to subtract 92 minus 54. So we will get, so the atomic number is 38. So we can write here 38. Part D, xenon 140 is a radioactive. It decays by beta emission to isotope Q. Determine the proton number of Q, the nucleon number of Q. So here we have xenon 140. which decays a beta negative emission. So a beta always represent -1 and 0. This one you are already supposed to know. And we have another element also produced, but we don't know what is its mass number, the number of protons and the total nucleon number. Here also we can use the same concept, that is the total mass number or the total nucleon number at the RHS and at the LHS must be same. So it also for Q it must be 140, then at both RHS and LHS it will be same. So that the nucleon number is 140. Now we need to find out what is the proton number. Again the proton number at the LHS and the total proton number at the RHS must be same. So at LHS it is 54. In order to get 54 at the RHS, for Q it must be 55. Then only 55 plus -1 we will get 54. Therefore we can understand for the Q the proton number must be 55.